The James Webb Space Telescope, JWST, has uncovered a stunning phenomenon. Beams of light appear and emanate from what seems to be a distant urban area, located several light years from Earth. This discovery has reignited speculation about the existence of extraterrestrial civilizations. JWST directed its attention to Proxima Centauri b, the closest known exoplanet to our solar system, where it detected unusually intense flashes of light. Could these signals be evidence of an advanced alien society? The world waits eagerly for more updates. For years, both scientists and the public have been fascinated by the idea of life beyond Earth. Every potential clue stirs excitement and wonder. A major breakthrough came when JWST captured data that could point to the existence of life elsewhere in the cosmos. While scanning the vastness of space, the telescope detected lights on a distant exoplanet that resembled those from human-made cities, hinting at the possibility of an alien metropolis. This astonishing find has sparked excitement across the scientific community. It raises the prospect that intelligent life forms may be developing civilizations far beyond our current understanding. What's even more incredible is that these city-like lights were detected from roughly 4 light-years away. NASA engineers are now contemplating how long these lights might have been visible in the cosmos, simply waiting for our technology to evolve enough to see them. Astronomer David Kipping from Columbia University remarked on the planet's complexity. Unlike most rocky planets, which absorb sunlight and radiate heat as infrared energy, Proxima Centauri b behaves unusually due to its close interaction with its host star, Proxima Centauri. This discovery highlights JWST's remarkable capabilities. Its ability to capture infrared wavelengths made it possible to detect the planet's strange behavior, crucial for understanding its atmosphere. Researchers plan to continue using JWST to examine the exoplanet's atmosphere in greater depth, assessing whether it might be habitable. JWST is particularly skilled at detecting faint infrared light, which allows it to observe activity on Proxima Centauri b even on its night side, something many telescopes struggle with. Its sensitivity enables it to pick up even the faintest signs of artificial illumination, provided they fall within a very specific and narrow frequency range, much narrower than the light typically emitted by stars. Proxima Centauri b has a dynamic and intense relationship with its star, heavily influencing its environment. Like Earth, it experiences day and night cycles, though with more extreme temperature swings. If the planet has an atmosphere, the contrast between its scorching day side and frigid night side will be pronounced. These dramatic temperature fluctuations offer vital clues about its atmospheric makeup. JWST's infrared imaging capabilities allow it to study these thermal patterns and potentially reveal whether an atmosphere exists. Interestingly, the telescope's orbit around Earth aligns with Proxima Centauri b's 11.2-day orbital period, enabling scientists to closely observe the planet's daylight cycles. If Proxima Centauri b does have an atmosphere, the next step will be to analyze its chemical composition. Scientists would look for key biosignatures, such as oxygen, water vapor, and methane, compounds that could suggest the potential for life. This process involves studying how starlight filters through the planet's atmosphere, a highly complex but promising method. While JWST excels in this domain, the journey to confirming life on another world has only just begun. While the James Webb Space Telescope, JWST, was not specifically designed to study planetary atmospheres, it has proven highly capable in analyzing certain elements, particularly water vapor, carbon dioxide, and methane. However, it struggles to detect free oxygen, a critical biosignature associated with life. Still, JWST can identify other key atmospheric indicators like ozone, which suggests a stable and potentially life-supporting atmosphere. As scientists continue analyzing the data collected by JWST, the search for habitable worlds presses forward, bringing us ever closer to answering the age-old question: are we alone in the universe? It's important to note that JWST can observe only a limited number of nearby exoplanets in detail. For more comprehensive atmospheric analysis, astronomers are looking to ground-based telescopes, such as the Extremely Large Telescope, JWST, scheduled to begin operations in 2027. With its advanced capabilities, the JWST will offer a deeper and more precise look into the atmospheric makeup of distant exoplanets, delivering clearer insights into their potential to host life. Despite its limitations, the JWST remains a vital instrument in the exploration of distant worlds, providing crucial data that may reshape our understanding of what lies beyond our solar system. Looking ahead, researchers have bold plans for future space telescopes that aim to overcome current observational challenges, especially the problem of intense starlight, which often overwhelms the faint glow reflected by orbiting planets. To address this, scientists are developing breakthrough technologies. One such innovation is the coronagraph, a device built into telescopes that blocks out the overwhelming light of a star while allowing planetary light to pass through. By manipulating light waves, coronagraphs can dramatically reduce stellar glare, making it easier to detect the dim signal from surrounding planets. Another promising solution is the star shade, a large flower-shaped spacecraft that would fly in formation with a telescope positioned tens of thousands of kilometers away. It would block the star's light before it even reaches the telescope's instruments, enabling direct observation of exoplanets, particularly those in a habitable zone where liquid water and potentially life could exist. However, these approaches require exceptional precision. For example, aligning a star shade perfectly across vast distances demands accuracy down to fractions of a millimeter. These technologies must also be engineered to function reliably in the harsh conditions of space, requiring miniaturization, energy efficiency, and resilience. Despite these engineering challenges, the potential rewards are immense. Successfully observing and analyzing exoplanet atmospheres could reveal biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor, in specific proportions. Such discoveries could point to biological activity, offering compelling evidence that life exists beyond Earth. Scientists are also working toward capturing direct images of these distant worlds in greater detail. Future telescopes equipped with adaptive optics, which compensate for distortions caused by Earth's atmosphere or the telescope's movement, could produce sharper, more detailed images. Combined with starlight blocking tools, these technologies may one day allow researchers not only to detect exoplanets, but also to map their surfaces and study their climates. The development of next-generation space telescopes marks a major leap in humanity's quest to answer one of its most profound questions. Are we alone? As our tools for observing distant planets grow more advanced, we move ever closer to uncovering the truth. If life exists beyond Earth, it could fundamentally transform our understanding of our place in the cosmos. Today, the search for extraterrestrial life and the future of space exploration are advancing at an unprecedented pace. As scientists and astronomers probe deeper into the mysteries of distant exoplanets, the James Webb Space Telescope JWST is ushering in a groundbreaking era of discovery. JWST's data is helping researchers uncover vital clues about the structure, composition, and potential habitability of far-off worlds. With each new insight, we move closer to answering the age-old question: are we alone in the universe? One particularly exciting focus is Proxima Centauri b, the closest known exoplanet to our solar system. This rocky planet has been the subject of intense scientific interest for years. Until recently, however, detecting definitive signs of life, such as artificial illumination or traces of alien civilization, remained a distant dream. Now, the JWST's detection of unusual light emissions from Proxima Centauri b has reignited hopes that intelligent life may exist elsewhere in the universe. Such discoveries fuel both scientific curiosity and public imagination, inspiring new generations to think beyond the bounds of Earth. JWST isn't only searching for artificial lights. It's also analyzing planetary atmospheres, their chemical compositions, potential biosignatures, and environmental conditions that might support life. Detecting gases like methane or carbon dioxide in just the right concentrations could indicate biological activity. The JWST's advanced instruments allow it to examine these atmospheric elements with a level of precision unmatched by any previous telescope, shining a new light on the habitability of distant planets. One of the most compelling aspects of Proxima Centauri b is its location within the habitable zone of its star, the region where temperatures may allow liquid water to exist on a planet's surface. Water is a crucial ingredient for life as we know it, making such planets prime targets for future exploration. Moreover, upcoming missions will also focus on how exoplanets interact with their host stars. Some like Proxima Centauri b, may be tidally locked, meaning one side always faces a star while the other remains in perpetual darkness. This creates extreme temperature contrast that can significantly impact a planet's climate and its potential to sustain life. Understanding these dynamics is vital to evaluating a planet's true habitability. Another major leap forward in the hunt for life involves technologies that can block the blinding light of stars, which otherwise makes it nearly impossible to observe the faint light from orbiting planets. Instruments like coronagraphs and star shades help telescopes isolate this planetary light, which carries critical information about surface conditions, atmospheric makeup, and possible life-supporting elements. One of the most thrilling advancements in this area is the potential for direct imaging of exoplanets. By combining adaptive optics and light-suppressing instruments, astronomers hope to capture high-resolution images of planets as they orbit their stars. These images could reveal atmospheric properties, chemical compositions, large-scale weather systems, and even surface features like oceans or land masses, offering humanity its first visual glimpses of other Earth-like worlds. As global efforts to explore space intensify, the JWST, alongside future telescopes, will play a pivotal role. Its ability to detect faint energy signals, analyze atmospheres, and search for biosignatures is revolutionizing modern astrophysics. With every technological breakthrough, we draw closer to discoveries that could redefine our understanding of life in a universe. This rapid progress in space science and astrobiology is opening doors that were once the stuff of science fiction. Researchers are venturing deeper into the cosmic unknown, with the JWST leading a bold new chapter in exploration. The treasure trove of data it provides is already reshaping our understanding of distant planetary systems. Every new observation brings us one step closer to answering one of humanity's most profound questions. Are we truly alone? The discovery of Proxima Centauri b's intriguing features may represent just the beginning of a transformative era in the search for extraterrestrial life. As our closest stellar neighbor, Proxima Centauri b has long been a key target for scientific investigation. Now, with possible signs of artificial light and favorable planetary conditions, it could mark the first turning point in how we approach the search for life beyond Earth.